Hello everyone. In the previous video, that is video 2, we have seen about forward differences, a forward difference operator and forward difference table, right? Now in this video 3, what we will do is we will see one example on how to form a forward difference table and find a particular value from the table. Fine. After that, we will be getting to know about backward differences. We'll getting to know about backward differences, backward difference table, and backward difference operator, and one example for that in today's video, that is video 3. Fine. For the example on forward differences, here is the question. Construct a forward difference table from the following data and write down the values of forward delta f of 10, forward delta square f of 10, forward delta cube f of 15, and forward delta power 4 f of 15. We need to first construct the forward difference table for the given data. Then we need to write down the 4 values, what he is asking. So here is the data what he gave us, x values and its corresponding y values. Y values to the corresponding x values are given, right? So how to form the forward delta table? I have x values. From there I have written in the table. I have 10, 15, 20, 25, 30, 35. So I have written over here x values. Fine. Then I have y values as from the table 19.97, 21.51, all those I have written over here, right? How to find forward differences? The other day we have seen how to find forward differences. We forward difference of y naught, right? Here previously in the general table you had values like this. If you remember, you had this as first value as x naught, x1, x2, x3, x4, x5, right? Then this is y naught, which is nothing but f of x naught, right? What is x naught value? 10. That means this will be f of 10 value, y naught. Then this will be y1, y2, y3, y4, and then y5. You have y5. Fine. Now what did we see the other day? Y1 minus y0, that is second term minus first term, will give you forward delta y0. Y2 minus y1 will give you forward delta y1, y2 minus y1. Similarly, you will do y3 minus y4, then y4 minus y3, then you will do y5 minus y6, and you will write in the third column. Yes or no? So y1 value is, I am doing y1 minus y0. y1 value is 21.51 minus y0 value is 19.95 minus. So we are not supposed to do manually. If you keep doing manually, you you go somewhere, end up somewhere, you take a lot of time. So for numerical analysis, you will be using scientific calculator, not the regular calculator. You will get scientific calculator, you will be using scientific calculator. So now I am using my scientific calculator and I will subtract the numbers. I am subtracting 19.95 from 21.51, that is 21.51 minus 19.95. The answer is 1.56. So I am writing here, this is my forward delta y. I'm writing in between these two, y0 and y1, I'm writing delta y0 value, that is 1.56. Fine. Then next what should I do? I'll subtract 21.51 from next value, y2 value, 22.47. I'll get 22.47 minus 21.51. Answer is 0.96. Next, y3 minus y2. What is y3 value? y3 I have 23.52 minus y2 value is 22.47, 1.05. Then I am doing y4 minus y3, right? y4 value is 24.65 minus y3 value is 23.52. The answer is, once again, 24.65 minus 23.52. The answer is 1.13. Then I'm doing y5 minus y4, that is 25.89 minus 24.65, 1.24. Right? This is my delta by first forward difference column I got. Right? So what will be this value? First value will be forward. Which side should I write? I'll write here very small. Forward delta y0. This is forward delta y1. This is forward delta y2. Forward delta y3. This is forward delta y4. These are my values. So now I'm going to find the second differences. That is forward delta square y. How to get those? I should subtract here forward delta y1 minus forward delta y0. I'll get forward delta square y0. Right? Now I'm going to subtract. I have forward delta y1 value as 0.96 minus first forward delta y0 value is 1.56. 0.96 minus 1.56. I'll get minus 0.6. Fine. Next, I have 1.05 minus 0.96. 0.09. Next, I'm subtracting delta y3 minus delta y2. That is 1.13. 1.13 minus 1.05. What's the answer? I'll get 0.08. Then if I subtract 1.24 minus 1.13, what will I get? I'll get 0.11. Fine. These are my second forward differences. Yes. Okay. What is the first value denoted by the second forward differences? What's the first value denoted? First value is denoted by this value minus 0.6 is forward delta square y0. This is forward delta square y1. This is forward delta square y2. This is forward delta square y3. Fine. Now I'm going to find forward delta cube y. How to get these values? You'll subtract the previous column values, y values. Delta square y1 minus delta square y2 will give you forward delta cube y0. Fine. So I have I have 0.09 minus of minus. Subtraction is there. This is 0.09 minus 0.6, which will become 0.09 plus 0.6. Fine. 9 plus 6, 15, 0.15. Fine. I'm sorry. 0. We'll get the answer as 0.09 plus 0.6, 0.69. So the value over here is 0.69. Then you have, what do you have? We have the next subtraction. Do the next subtraction. You have 0.08 minus 0.09. So what will be the value? There's a just difference of 1 point over there. So you'll get negative 0.01. You get here, if you subtract 0.09 minus 0.08 minus 0.09, you'll get it as minus 0.01. Fine. Then if you subtract 0.11 minus 0.8, you'll get it as 0.03. Fine. This is your third differences. So what are these values? What you have? You have the values of forward delta cube y0, forward delta cube y1, forward delta cube y3. Fine. Next column will be forward delta power 4y. What is this? Subtract. Minus, you have minus 0.01 minus 0.69. The answer is minus 0.7. So I'll write here, it is minus 0.7. Then what is 0.03 minus of minus? So I'll have plus 0.01. The value is 0.04. Here you have 0.04. So the finally I have delta power 5y. So what will I get here? I have 0.04 minus of minus 0.01. So it is 0.04 minus of minus means plus 0.7. I'll have the value as 0.74. This 0.74. Should I do the next column? There's no possibility of doing next column because there is no two elements. I have ended up with one element in the column, so I'll end here. Fine. So what are the values of these? I have delta power 4 y0. This is delta power 4 y1. And this is delta power 5 y0. So these are the values we have done for forward differences for the given set of data. X and y values were given. We have found out filled the forward difference table. Right? Now, what was the next continuation of the question? He asked us to find a few values. What are those values? I'll show you. First value is, I have to find out forward delta f of 10. Fine. How to find forward delta f of 10? I have I want to find forward delta f of 10. What is forward delta f of 10? Where is 10? 10 means what you'll write generally, you'll write it as f of x equal to y. Yes or no? In place of x you have 10. So where is 10 in the table? In x column. Fine. Where is x column? In 10. That is in the first position. That means x naught. This is nothing but forward delta f of x naught. Yes or no? X naught is 10. How to represent in y? Forward delta y naught. Yes or no? F of x is y means f of x naught is y naught. So what is forward delta y naught value from the table? See here, my forward delta y naught value is 1.56. So we have found the value. What is the next value asked? He is asking forward delta f of forward delta square f of 10. Right? This is nothing but forward delta square f of, where do you find 10 in x column? First position. That is nothing but x naught, which will be equal to forward delta square. What is f of x naught? Y naught. Where is forward delta square y naught? This position. So the answer is minus 0.6. Then the next question was forward delta cube f of 15. What is f of 15? Forward delta cube f of, where do you find 15 in x column? Second position. Second, that is x1. So what is f of x1? F of x1 is forward delta cube y1. Where is forward delta cube y1? Search for forward delta cube y1. This part, forward delta cube y1 is minus 0.01. Similarly, you will find the last value, that is forward. The question you have forward delta power 4 f of 15, which is forward delta power 4 f of, where do you find 15? In the second position, that is x1. So this is nothing but forward delta power 4 y1. Search for forward delta power 4 y1. This is your value. 0.04 is your answer. 0.04. Fine. So this is how we have formed the forward difference table and the values he asked us to find out. 4 values he asked us to find out. We have found out after filling the table. Fine. You should be very careful in filling the table. Fine. Then only you will be able to get the required values. Once your table, the values in the table are wrong, whole sum will be not correct.
Recording in progress.
So now we'll get to know about backward differences. Fine. What all I need to construct my backward differences? First I need a function. So I'm writing considering y equal to f of x, where what is x? X is an independent variable. X is an independent variable, y is dependent variable. Right? Next, I need the values. So I'll take let y naught, y1, so on, yr, so on, yn be the values of y. Values of y corresponding to the values corresponding to the x values. What are those x values? x0, x1, so on, xr, so on, xn of x respectively. Fine. So I have considered the function y equal to f of x and I have taken the general points x0, x1 to xn and y0, y1 to yn. Right? The differences, how to do the difference? Second term minus y1, first term only. The differences y1 minus y0, y2 minus y1, so on, yr plus 1 minus yr so on, yn minus yn minus 1 are called first backward differences of y, are called first backward differences of y. How are they represented now? How are backward differences represented? The symbol is in the other way. Fine. How are backward differences represented? They are called first backward differences. They are represented as this symbol, backward difference y1, backward difference y1, backward difference y2, so on, backward difference yr, backward difference yr, and so on. This is the representation. So how it goes, we'll see. Fine. What will be backward difference? That is, what is backward difference y1? This is y1 minus y0. What is backward difference y2? This is y2 minus y1. What is backward difference y3? y3 minus y2. Fine. Okay. So on. What will be backward difference yr? This will be yr minus yr minus 1. What is it? Okay, now I have written something similar only to forward differences. But what is the variation here and there? What is the difference? There, if you observe, it was y1 minus y0 only. y1 minus y0 only. y1 minus y0 was represented as forward delta y0. The second position was represented, right? y2 minus y1 was represented as forward delta y1. This position. In A minus B, the B position was represented in forward differences. Now what is happening in A minus B? The A position is represented in backward differences. That is a notation difference. There is a difference in the writing of the notation, but the way you subtract is same. y1 minus y0, y2 minus y1, y3 minus y2 is same. Notation is different. Fine. Okay, I hope you have got the logic how to write the second differences now. Fine. So let's start doing the second backward differences. Now we have seen the first backward differences. Backward delta y1, backward delta y2, backward delta y3. Fine. So now what is this symbol called as? And here the things goes on. This symbol, the symbol, this one, backward delta, is called as backward difference operator. Backward difference operator. Fine. This symbol was called as forward difference operator. Now this symbol is called as backward difference operator. Fine. Now shall we write? Once I'll show you how did we get. We have defined a function and we had the general points x0, x1, so on, and the corresponding y values are y0, y1, so on. So the differences are called as first backward differences of y. That is y1 minus y0, y2 minus y1, so on. How to represent? It is represented as backward delta y1. What is backward delta y1? It is y1 minus y0. What is backward delta y2? It is y2 minus y1, and so on. Now how to write the second differences? I should subtract these two. Forward delta y2 minus forward delta y1 will give me, I'm sorry, backward delta y2 minus backward delta y1 will give me second difference, that is backward delta square y, what's the symbol? I'm writing here, backward delta y2 minus backward delta y1. What is the symbol I should write? The first position. In A minus B, the first position I should write. So I'll get, when I subtract first differences, I'll get second differences. Fine. Now, shall we do the second differences of backward? No. So how to write the general term? I have written the general term. Fine. Delta R is written. Now the second backward differences. I'll write here forward delta y1, forward delta y2, backward delta y1, backward delta y2, backward delta y3, and so on, backward delta yr, comma, so on. R, what are these? Are first backward differences now. How to get the second backward differences? Second backward differences. Differences are, how to get? I should subtract these, no? These. So I'll write here backward delta y2 minus backward delta y1. Next one will be backward delta y3 minus backward delta y2, and so on. Fine. How are they denoted? They are denoted as second differences, no? Backward delta square, what is the notation? First position I should take. Backward delta square y2, backward delta square y3, and so on. This is what is the notation. Right? Next, how to do the next differences? Once we'll see the values, how to write here. That is backward delta square y2 is nothing but backward delta y2 minus backward delta y1. What is backward delta y2 formula? What is backward delta y2 value? Scroll up. Backward delta y2 is y2 minus y1. Backward delta y2 is y2 minus y1. Minus, what is backward delta y1? It will be y1 minus y0. So shall we simplify this? We'll get y2 minus y1 minus y1 minus into minus plus y0. So this value is y2 minus 2y1 plus y0. This is my backward delta square y2 value. Fine. Next one. How to get backward delta square y3? What is this? Backward delta y3 minus backward delta y2. What is backward delta y3 value? It will be y3 minus previous term y2 minus backward delta y2 will be y2 minus y1. We'll simplify this. I'll get it as y3 minus y2 minus y2 minus into minus plus y1. So the final simplification is y3 minus 2y2 plus y1. This is how we have the backward delta square y3 value. So next, what we'll do next? We'll fill the values in the table. I'll show you the backward difference table. What all we have in the table? We have the values of x. Then we have the values of y. Then I'll have first backward differences delta. Then second backward differences, backward difference operator square. Then you will have third backward differences. Fine. So what were the values I had? I had the values x0, x1, x2, x3, I'm showing till x4, 5 elements I took. So corresponding y values will be y0, y1, y2, y3, y4 I took. So what is backward delta? Delta? It is same, y1 minus y0 only. You will write here y1 minus y0. Here you will write y2 minus y1. Here you will write y3. Here you will write y3 minus y2. Here y4 minus y3. But what is the notation? This is backward delta. You will notate the previous one. Next one. Backward delta y1. This is backward delta y2. This is backward delta y3. This is backward delta y4. What will be the next differences you'll have? What's the difference? Next difference, backward delta y2 minus backward delta y1. What you'll get? Backward in between these two. You'll get backward delta square, and I'm not writing here the symbol. We'll see what you'll get. We'll have to get this minus this, no? Backward delta y2 minus backward delta y1. Next one will be backward delta y3 minus backward delta y2. What will be the notation? Backward delta square y. What should I take? I should take this notation, A position, 2. Here it will be 3. Then I'll get backward delta square y, backward delta y4 minus backward delta y3. So it is backward delta square y4. These are your second differences. What will be your third differences? It is backward delta cube y3 equal to backward delta square y3 minus backward delta square y2. Then here you'll get backward delta cube y4. This is backward delta square y4 minus backward delta square y3. This minus this. This minus this. Delta square y3 minus delta square y2. This is your third backward differences. Fine. This is your third backward. Then fourth backward differences will be backward delta power 4 by 4 will be your answer. Fine. So here you will get backward delta by 4. Backward delta cube by 4 minus backward delta cube by 3 will give you backward delta power 4 by 4. Fine. So this is your table for backward differences. First backward difference column, second backward difference, third, fourth, you have. Fine. For 5 elements, you get 4 columns. Right. So next what we will do, we have filled the column. I have shown you what is backward difference operator, what is backward differences, how to find, and then how to fill the table. Fine. Only the notation is different. The way you subtract is same. Again, I'm saying you, for forward differences, backward differences, the way you subtract is same. The notation is different. How you notate the particular position is different. Fine. Shall we see one example now for backward differences? Why to do one more example? Shall we write down the values from the previous example, what we have done for forward? I'll show you the sum. We'll take down the question differently. Fine. Now, this table, the difference, the values will be same. Once you subtract, the values will be same. Only the notations will be different. No. So if suppose in the same question, if my sum, fill the backward difference table and find few values. What will be the values? Okay. Before writing the values, what we'll do is, shall we write the notations of these in the same question? We'll understand the difference, what is happening actually. Fine. Okay. Here I had x0, x1, x2, y0, y1, y2, same. What will be the first position denoted as? What will be the first position denoted as? I'm just erasing these circles. 1 second. It was 1.56. No? I'm writing this as 1.56. It was forward delta y0, right? So what will be the notation for backward? I said the first position is denoted as backward delta y1, same value. This will be backward delta y2. This will be backward delta y3. This will be backward delta y4. This will be backward delta y5. This is backward delta square y1. This is backward delta square y2. Backward delta square y3. Backward delta square y4. Why? Because I said y1 minus y0. I said y1 minus y0. The same thing. Y1 minus y0 is denoted as backward delta first position when you are denoting with backward. Right? Then y1 minus y0 value only is denoted as forward delta. When you are denoting with forward delta, it is denoted with second position. Right? Value is same, y1 minus y0 only. Notation is different. Right? So what will be this 0.69 value? Backward delta cube y1. This will be backward delta cube y2. This will be backward delta cube y3. Then this will be backward delta power 4 y1. This will be backward delta power 4 y2. The last one will be backward delta power 5 by I'm really sorry. I'll just back these steps and do the notation again. Till here it is there. 1 second. You have backward delta square. Here it went wrong. Here first position will be this backward delta square y. No, what is this? Backward delta y2 minus backward delta y1. So I should denote with y2. No, I'm really sorry. This will be backward delta square y2. Then this value will be backward delta square. This will be backward delta square y3. This will be backward delta square y4. This will be after delta square y5. This will be backward delta cube y3. This will be backward delta cube by 4. This will be backward delta cube by 5. This is backward delta power 4 by 4. This is backward delta power 4 by 5. This is backward delta power 5 by 5. This is how the notation goes. What you do is you clearly, how we did for forward differences, you please write the table and you do the notation clearly. You won't get any mistakes. You won't get any confusions also. Fine. If you want, I'll show in the next class. I'll show for once again how to represent the backward differences. I'm ending today's class over here.